Okay, in this tutorial we're looking at section 8.5, which is on integrals of powers of trigonometric functions. In this section we solve integrals of the form integral of sine to the power m of kx times cos to the power n of kx dx, where m and n are both integers. Okay, integrals involving sine squared kx and cos squared kx, well, we can remember that we have some various different formulas that we can use. So we've got sine of 2a equals 2 sine a cos of a, cos of 2a equals cos squared of a minus sine squared of a, or 2 cos squared of a minus 1, or 1 minus 2 sine squared of a. Okay, and rearranging some of these, we also see that sine squared of a equals a half outside of 1 minus cos of 2a, and cos squared of a equals a half outside of 1 plus cos of 2a. Okay, so we'll have a look at some worked examples. Okay, so the first one is worked example 21, and we're integrating cos squared of 3x dx. Okay, what we're going to do is straight away use one of our identities. Okay, so what we're going to do is we're going to use our identity here. Okay, and say, well, that's the same as integrating, okay, with bringing our half out the front, okay, of 1 plus cos of, now we've got to go 2a, so we've got to double this and make it 6x dx. Okay, and when we do that, we get our half outside of, well, integral of 1 is x, integral of cos of 6x is 1 on 6 sine of 6x, okay, plus our c. Okay, so we can say that that's equal to x on 2 plus 1 on 12 sine of 6x, okay, plus our c. Okay, and we're done with that one. For part B in this one, we're integrating sine squared of 3x cos squared of 3x with respect to x. Okay, so what we can do is we can use one of our identities again, okay, and say that that's really the integral of a quarter, well, we bring our quarter out the front, of 2 sine of 3x cos of 3x squared dx. Okay, and that's using our double angle formula, 2 sine of a cos of a, okay, equals sine of 2a. Okay, so we're using that with a equaling 3x. Okay, and that means that sine squared cos of a cos squared of a, right, is equal to a quarter, okay, of sine squared of 2a. So basically, if we squared both sides of this, okay, we get our 4 sine squared cos squared of a equaling sine squared of 2a. Okay, we can divide by our 4, so that gives us our quarter over there. So that's the idea with what we've done there. Okay, and so what we can do then is say that we've got a quarter outside of sine squared of 6x dx. Okay, and so what we can do then is use our sine squared formula. Okay, and so we'll get another half again, so we'll bring that half out and make it an 1/8, okay, of 1 minus cos of 2a, so we need to double our a, so it's going to go to 12x dx. Okay, so that simply becomes our 1 on 8 outside of x. Take 1 on 12 sine of 12x, okay, plus our c. We can just run through our 8 and say that we've got x on 8 minus 1 on 96 sine of 12x plus c. Okay, so keep moving on with our worked examples. There's a few to get through. So we look at integrals involving sine of kx cos to the power m of kx and cos of kx sine to the power m of kx, where m is greater than 1. Okay, so this is worked example 22, and what we're going to do is we've got to integrate sine of 3x cos to the power 4 of 3x with respect to x. So what we need to do is let u equal cos of 3x. Okay, that means that our du dx is going to equal negative 3 sine of 3x. Okay, so dx on du is equal to our 1 over negative 3 sine of 3x. Okay, so our dx is equal to our negative 1 on 3 sine of 3x du. Okay, so what we're going to do then is bring it all together, okay, and say, well, we're integrating sine of 3x, okay, and now our u is equal to cos of 3x, so it means that we've got u to the power of 4, okay, times by negative 1 over 3 sine of 3x du. Well, our sine of 3x and our sine of 3x can cancel out, and we can bring out our negative 1 on 3, so we've got negative 1 on 3, okay, of u to the 4 du. Okay, so when we do that, we can say we've got negative 1 on 3, okay, times by our u to the 5 on 5, okay, plus c. So we can say we've got negative u to the 5 on 15 plus c. Okay, sub our cos of 3x back in, and we get negative cos to the 5 of 3x on 15 plus c. Okay, to finish it off. If we look at worked example 23, okay, this time we're going to integrate sine cubed 2x cos to the 4 of 2x dx. Okay, so what we can use is we can actually break this up a bit, okay, and what we're going to say is we've got sine of 2x times sine squared of 2x. Okay, so we're going to get sine of 2x sine squared of 2x, okay, cos to the 4 of 2x dx. Okay, we do that then because we have an identity that we can use here. Okay, so we can use our identity sine squared of a equals 1 minus cos squared of a. So when we do that, okay, we say we're integrating sine of 2x, okay, times by 1 minus cos squared of 2x, okay, times by our cos of 4, cos to the power 4 of 2x dx. So we've only changed around this part in there. Okay, what we do now is we say, well, let our u equal cos to the 2x, cos of 2x, sorry. So our du dx, okay, equals negative 2 sine of 2x. Okay, so when we rearrange that, we get dx equals 1 over negative 2 sine of 2x du. Okay, so now we can put it all together, okay, and we get our integral of sine of 2x, so 2x, okay, times by 1 minus, well, cos of 2x, okay, was u, so we say 1 minus u squared, okay, times u to the 4 times negative 1 on 2 sine 2x du. So our sine of 2x and our sine of 2x can cancel, and we can bring our negative a half out the front and say that we've got negative 1 on 2, okay, integral of, now we can multiply out by our u to the 4, so I'm going to say u to the 4 minus u to the 6 du. Okay, going to be the easiest way to do that. So then we've got our negative a half, okay, outside of u to the 5 on 5 minus u to the 7 on 7, okay, plus c, which means we've got negative u to the 5 on 10 minus, plus u to the 7 on 14 plus c. Okay, and then what we can do is we can sub in our u again, and we'll just put our highest degree first. So our u was cos of 2x, so now we're going to be cos to the power of 7 of 2x minus, on 14 minus cos to the power of 5 of 2x all on 10 plus c. Okay, to finish off that worked example. Okay. Screen there, so we'll have a look at worked example 24 now. Okay, so we're integrating cos to the power of 4 2x. Okay, so what we can do there is we can say, well, that's really cos squared of 2x all squared dx. Okay, and when we can change our cos squared of 2x, we can use one of our identities to say, well, that's really a half outside of 1 plus cos of 4x. Okay, because it was, we say this is a and this becomes cos of 2a, so we're going to double it. Okay, and that's all squared dx. So what we can do is we can bring out, so from here, what we can do is expand this out. Okay, so we've got, oh sorry, that squared is around that as well. Sorry. So we bring out our half squared is a quarter, so we bring out a quarter. Okay, and then what we can do is expand out these brackets and say, well, we'd have 1 squared is 1. Okay, plus we'd have 2 lots of cos of 4x, because we go 1 times cos of 4x and cos of 4x times 1, so we get 2 lots of them. Okay, and we're also going to get cos squared of 4x, okay, dx. Okay, so we're getting there, but okay, we need to do the same thing as what we did up here, but just with this one. Okay, which means we're going to get a half out the front again of 1 plus cos, we're going to double this to make it 8x dx. Okay, so what we can do there is we can say, well, we've got 1 on 4 outside of, well, a half, okay, plus our 1 is going to give us 3 on 2, okay, plus we've got 2 cos of 4x, okay, plus we've got our half times our cos of 8x, okay, dx. Okay, so we can finally start to get somewhere now and actually do our integration. Well, so 3 on 2 is going to become 3x on 2. Okay, we've got to bring our 4, we've got to divide by our 4 here, so it'll be 2 on 4, which is a half sine of 4x. Okay, we've got to divide by 8, so that's going to become 1 on 16 sine of 8x. Okay, and of course we're going to have plus c on the end. Okay, and we can simply multiply through by our quarter to say we've got 3x on 8 plus 1 on 8 sine of 4x, okay, plus 1 on 64 sine of 8x plus our c. Okay, so a little bit of work to do there. We have to use our double angle formula twice. Okay, so we'll keep going. We've got 2 more worked examples to look at. We've got worked example 25, okay, which is integrate tan of 2x dx. So what we can do with that and say, what we're going to integrate sine of 2x on cos of 2x dx. Okay, we'll let u equal cos of 2x. So our du dx equal negative 2 sine of 2x. Hey, when we rearrange for dx, we get dx equals minus 1 on 2 sine of 2x du. Okay, so what we can do is set up our integral now and say, well, we're integrating sine of 2x over u times negative 1 on 2 sine of 2x du. Okay, we can bring our negative half out the front. Okay, our sine of x and our sine of x are going to cancel out, so we'll have 1 over u left, okay, which is u to the negative 1 or du, okay, and that simply goes to negative a half log to the base e of the modulus of u, okay, plus c. Now we've got to sub our u back in, so we're going to be negative a half log to the base e of the modulus, where our u was cos of 2x, okay, plus c, to finish that one off. Okay. Now we can actually bring our negative up and say that we're half log to the base e of the modulus of cos of 2x to the power negative 1 plus c, which means you get a half log to the base e of the modulus of, well, inverse cos is the same as sec, so we get sec of 2x plus c. If you'd stopped here, it still would have been fine, but just to show the last two steps that they do in the worked example. Okay, now we've got one last one to go. Okay, so we need to integrate tan squared of 2x. Now what we need to do is use the identity that 1 plus tan of a equals, sorry, tan squared of a equals sec squared of a. Okay, so that means that we can say then, by rearranging it, okay, that tan squared of a equals sec squared minus 1. So we can say that we're integrating sec squared of 2x minus 1 dx. Okay, and we know that when we integrate sec squared, it goes to 1 on k, which is our k is our 2, so it's going to be 1 on 2 tan of 2x, okay, minus x plus c. Okay, so just that last step, we've got the identity that the integral of sec squared of kx equals 1 on k tan of kx, okay, plus c. Okay, so it's just using that identity on here, okay, just on this part, to get our 1 on 2 tan of 2x. Okay, we're going to integrate our minus 1, makes it minus x, plus our c. So that's all we've got in this section in terms of worked examples. So I mean, there is a little bit of a recipe that we can follow a lot of the time with these. Okay, yes, we'll have to identify which of our identities to use, but essentially we want to get rid of our squareds when we can, okay, so that we get down to something that we can integrate a little bit more straightforwardly.